Hi, I'm Lucas from Infrafon. In many workplaces it can be challenging to keep track of which rooms need cleaning and which are already taken care of. This can sometimes lead to missed areas or duplicated effort. Today we'll set up a simple solution to help manage room cleaning status using an Infrafon device, a BLE beacon and stream sheets. This setup will make it easier for you to see which rooms are ready for cleaning and keep everything running smoothly. But before we dive into the specifics, I want to emphasize that the scenario and the technologies I'm demonstrating here today are just one example of what the Infrafon can do. The real strength of the Infrafon lies in its flexibility and its ability to work with a wide range of technologies. For instance, it doesn't matter what type of beacon you use. It could be a BLE beacon from Cisco, Aruba, or even another type of location tracking device. The same applies to the process engine. While Stream Sheets works great for this example, you can also use in other systems that support MQTT like Node-RED or Camunda, or even other similar protocols. Also, if this particular scenario doesn't match your needs, please don't hesitate to reach out. We're happy to consult with you, and we're confident that Infrafon can integrate seamlessly into your existing infrastructure. Whether it's cleaning management, resource tracking, or tackling another operational challenge, we'll work with you and to create a solution that fits. And now let's take a closer look at how the specific system works in practice. Imagine we are inside a building. I've sketched out a few rooms where we plan to place beacons. Each room requiring regular cleaning will have a beacon installed. When a member of the cleaning staff walks past the room with an Infrafon device, the device will detect the beacon's proximity and send this information to the Infrafon server. The server processes the data and sends a message back to the device, asking the staff member if they could incorporate this room into their schedule, as it has recently been marked for cleaning by a booking system, a sensor, or through manual input. Once the person leaves the room's proximity, the Infrafon device will recognize the movement away from the beacon and prompt them to confirm if the room can be marked as cleaned. If the cleaning is not marked as complete and the person doesn't return, the system will send a gentle reminder after 5 minutes. This system is particularly useful in settings where rooms are used on demand, so cleaning staff can't always follow a fixed schedule. By updating the room status in real time, the setup ensures efficient, responsive cleaning without missed areas. So now I'm going to walk you through the data view design process. We will create a data view for the Infrafon to manage the interaction with the cleaning staff. First, I will give you a short introduction to the data view designer and then we will get started. Okay, let's pick an appropriate name for the data view. We can also choose a text or a logo to be the icon of the app that will be displayed on the home screen of the Infrafon. Now I will create a text box to ask the person entering the room if they are here to clean it. We can place the text box on one of the different grid cells and also configure its size to the size of the text box if we need it to span over a bigger area. For that we are going to use the small white points on the edge of the text box and just drag it until it has the right size for us. As you can see, there are a lot of options customizing your text, size, alignment, what kind of element, and also the border. In this case, we just needed to display the text, so we're going to make it static. To make this more interactive, I'll add 2 buttons below the text box, one for yes and one for no. These buttons will allow the user to respond directly to our request. We also choose Update Remote instead of Go to Page, so the Infrafon can send JSON data to Stream Sheets and we can further process the data. In this case, registering that room X is getting cleaned by person Y. For the other button, Go to Page, is fine since it only brings us back to the home page. Now we are adding a new page where we confirm the decision of the user. The next thing will be a notification page where we ask the user if the room is cleaned. Next, we also need the inquiry page to remind the person that room X still needs cleaning, or if they just forgot to check out. Finally, we need to give the buttons that we use with the Update Remote configuration meaningful names, so we can use them with more ease in Stream Sheets later. Now we can download the JSON file and use it to allocate a device, and we are done. Now that we have designed the data view for the Infrafon device, let's move on to implementing the setup in Streamsheets. Streamsheets will handle the data coming from the Infrafon device and manage the interaction logic for the cleaning workflow. We will begin by configuring the MQTT connection, allowing Streamsheets to publish commands and subscribe to responses from the device. Once the connection is set up, we will send a scan command over MQTT instructing the Infrafon to scan for Bluetooth devices. This scanning is needed to detect nearby BLE beacons and measure their distance. To ensure the sheet updates consistently, we will adjust the inbox settings so that it recalculates every 5 seconds. This keeps the system responsive enough to work properly while also not congesting the MQTT channel. Next, we need to verify that the device is detecting the correct beacon. To do this, we will configure the inbox to subscribe to the topic where the device publishes its scan results. Then run the Streamsheets application to start the scanning process. Once data begins arriving, we will pause the application and drag the required fields into place. We will compare the MAC address the Infrafon found during scanning with the known address associated with the beacon. We also use the Streamsheets time aggregate function to aggregate the RSSI data, enabling us to create a nice plot. The RSSI value indicates the signal strength of the connection between the Infrafon and the beacon and helps us approximate the beacon's distance. Using this information, we will determine if the device is within close proximity to the beacon. To prevent repetitive MQTT messages while the device is near the beacon, we will introduce flags. The first one will check if the device is already close to the room, to avoid duplicate notifications. The second flag will check if the device has moved out of range, helping the cleaning staff to remember to mark the room as cleaned, while also preventing unnecessary message spam. The additional 2 flags will track whether the staff agrees to clean the room and whether the room has been cleaned already. Next, we will use a cell in Streamsheets if column to control an entire row with a single if function. Using one condition to control the entire row simplifies the process of chaining multiple commands that depend on the same logic. For example, when the device approaches a room, several actions need to take place. The row must set the relevant flags for this condition, which we achieve using the built-in setValue command. Additionally, the row needs to send an appropriate MQTT message to update the data view page, prompting the person to include the room in their schedule. Additionally, we will incorporate JSON data to the MQTT commands. The easiest way to do this is just to copy and paste the data from an editor. For simplicity's sake, we will use multiple data blocks for the different pages instead of changing the values in one data block or using something like a dictionary. We can do this because this is a small demo. A bigger project might require another solution. The MQTT commands include data to change the page on the Infrafon's data view. They also contain instructions to activate the Infrafon's vibration feature, ensuring that it catches the attention of the user. We will include further conditions directly into the cell of the MQTT command. They are different from the row conditions in that they are more specific. The entire row activates if the device gets near the room, but the cell should only activate when we still need to ask the person to include the room in their schedule. Similarly, we will apply the same logic when the device leaves a room that hasn't been cleaned, updating the flags and sending MQTT commands based on proximity and flag states. We will also configure actions triggered by button presses in the data view. For instance, when the B1 Yes button is pressed to indicate that staff have agreed to clean the room, the system updates the corresponding flag and switches to a page acknowledging their commitment. Similarly, pressing the B3 Yes button to confirm that the room has been cleaned updates the relevant flag and transitions the page to reflect this status. Finally, we will implement a reminder system to notify the staff if they leave a room without marking it as cleaned. This will utilize the built-in counter function, which we will configure to count from 1 to 300, which is equivalent to 5 minutes. Once the counter reaches 300, it sends an MQTT command to remind the staff and then resets. To prevent multiple reminders from being triggered, we will introduce an additional flag for control. The row processing order in Streamsheets, executing commands from left to right and top to bottom, ensures that the MQTT message is sent first, followed by the flag adjustment to avoid repetition. To ensure accurate timing for the counter, we will adjust the inbox settings so that it recalculates every second, rather than relying solely on incoming messages. Now you can see me walking into the beacon's range, where the device detects my proximity. As I move closer, the RSSI value increases, triggering a message on the device and the real-time updates to the flags. This activity is also reflected in stream sheets. Now I will respond to the message on the device and approve the request. This action triggers the top row in stream sheets, updates the flag, and sends an MQTT command to change the page on the device. You can also see how pressing a standard button takes us back to the home page. Additionally, you can see the MQTT message for the remote button update displayed on the left side in stream sheets. Afterwards, I will move out of the beacon's proximity. As I leave, the RSSI value drops, which automatically triggers a prompt in the system. You can see the value dropping in the RSSI graph on the right, as well as the flags indicating that the device is out of reach again. Finally, I will demonstrate what happens when I accept the prompt on the screen. Again, you can see how Stream Sheets immediately sends a command to update the page. Additionally, the corresponding flags and data in Stream Sheets are updated to reflect the room being registered as cleaned. Here we could also add a confirmation to the booking system. Thank you so much for watching. I hope this demonstration showed you how an Infrafon can simplify your workflows. If you have any questions or would like to explore how this could work for you, don't hesitate to reach out. We would love to help. Take care and see you next time.